Welcome to the Aaron Harber Show. This is part 2 of our special 2-part series with Dr. Bruce Gellin. Make sure you watch part 1, which is available now online. Bruce, thanks again for joining me.
Aaron, thanks a lot.
So I want to jump right into a number of different topics, starting with the overprescription of drugs. Talk a little bit about the challenges there today.
Of antibiotics.
Of antibiotics in particular.
Yeah, I think the challenge is the more you use them, you threaten to lose them. The bacteria are pretty smart, and if they're in an environment where there's a lot of antibiotics, they'll figure their way around it, and that's where resistance comes from. Now, as an infectious disease clinician, obviously antibiotics are quite important, but unless you are targeting the organism that's the problem, you're now going to have the potential to have much more resistance. So when people come into their doctor because they or their child are uncomfortable or have an ear infection or have a low-grade fever and expect an antibiotic, that antibiotic's a good thing to have if they have a bacterial infection, because antibiotics are for bacteria, not for anything else. And if people
like a virus.
Like a virus, right. So if people have a cold and they go to their doctor and they either get or want an antibiotic, that's not a good thing. It's not going to help them. But of more concern from a community standpoint is that the more we have this where people are getting antibiotics that they don't need and they're in our systems, the more the bacteria will become resistant to the point where the infections will be increasingly difficult to treat or maybe untreatable.
All right, so in that vein, I'd be really interested in terms of, we've always been a few steps ahead of many diseases in terms of antibiotic treatment. Most people, if they have some kind of bacterial infection, are usually started out with a lower level antibiotic. What's happened in terms of those levels and how effective they are? And do you have any kind of concern that we may see the appearance of some kind of superbug?
Well, I think that's what we're worried about in a broad way, is that the more we use antibiotics and the more they're in the system and they're in our systems and become in the environment, the more the bacteria will become resistant and the antibiotics won't work. So when a patient has an infection, it's best to know what their infection is so you can be very precise in your treatment. You don't always know that, so you try to give sort of a broad spectrum protection if you think that they have a bacterial infection. But if they have a virus, it's not going to do them any good. The other thing is which is underappreciated, is that antibiotics are drugs, and every drug has a good side and a bad side. And I think that we need to recognize that antibiotics are not only have an upside but could have a downside. And the more we use drugs that are not going to help us but could hurt us, the more we're going to have trouble.
What's the downside?
The downside could be many things. The downside could be that it affects different parts of your system. It could affect your blood or it could affect your platelets. There are a number of side effects from antibiotics that we have to worry about as well.
So when it comes to methicillin-resistant Staphylococcus aureus, or MRSA, where are we on that front? And certainly there are versions of MRSA that are really threatening.
No, that's really the case, is that MRSA has been around for some time, and as you suggested, that it's not only resistant to methicillin, but it could be resistant to broader antibiotics as well, which gets to the problem of the more you use antibiotics, the less they're going to be able to be used. On the other side of this is, as you said, that for a long time we've been a few steps ahead. And where we are now is that there's really not very much in the pipeline, in the development pipeline, because we're having increasing difficulty in making these antibiotics, and the pharmaceutical companies are having difficulty. There's a lot of internal competition about where they're going to make their investments, and antibiotics is a place where increasingly where companies are not making their investments.
So, we're not the 3 or 4 steps ahead of MRSA. We're maybe 1 step ahead at this point?
I don't know how many steps we are. It depends on where you are and what that bug is. I think the big message is this is a growing problem. That's a problem in the United States and a problem globally that increasingly there's been some attention paid to it, but we need to work a lot more on it.
How about MRSA in hospitals as well as other infections? It seems like that the best place, and I put best in quotes, to get an infection is in the hospital.
Well, I think that hospitals, you only want to be at a hospital if you have to be. because there are a lot of infections in hospitals, you want to make sure that you're not going to come out with an infection you didn't go in with. And I think that increasingly that's a concern. And what I worry about, you mentioned superbugs, what I worry about is that as the antibiotics that we have are less and less effective, we may be at a point, and people refer to this as the post-antibiotic era, where they don't have the impact that they have, where hospitals could be like they were in the 19th century, when they were places where you didn't want to go because these infections were rampant.
When it comes to superbugs, are we at the forefront, or are you aware of anything other countries are doing?
I think when it comes to concerns about antibiotic resistance, the United States and a few other countries are actually on it. I think the chief medical officer of Great Britain has been on this case for a long time, and I give her a lot of credit for giving this global attention. But increasingly, this is an issue that all are paying attention to. The World Health Organization has taken this to the United Nations. It's a huge issue, but there are many components to it. There's the human issue that we talked about. There is the issue of antibiotics in animals and the intersections of animals and people, and where we could have resistance coming from the farm and affect us as well. There are a range of these, and it is clearly an all hands on deck issue.
What can an individual do that may make him or her more resistant to various infections?
So let's be careful about how we use the word resistant. So we talked about antibiotic resistance and resistance to infections.
Right.
So let's just make sure, I mean, it's the right word, but right in the right context. So vaccines are an important way to protect people from getting infected in the first place. And there's a lot of work that's going on to use the vaccines that we have and to develop new vaccines to prevent some of these infections that are not yet vaccine preventable. Then there's the issue of when people are sick and the treatments that they get from antibiotics. What we worry about there is whether or not the bacteria have become resistant to the antibiotics. The third piece that you've suggested is that, is there something an individual can do to make them strong and healthy so they don't have to mess with any of this stuff? I think the reality is that the bugs are in charge here, that the bacteria and viruses that cause these infections, we need to be able to diagnose them and treat them quickly. We need to be able to prevent them with vaccines, and we need to make sure that people are aware of that, and we need to make sure that people are aware of that. I think it's good that people are exercising, it's good that people have good diets, but that alone is not going to protect people from bacteria and viruses.
So what might protect, looking into the future, what about the concept of genetic engineering? What could that do in terms of making it more difficult in terms of becoming ill, recovering faster, or even being able to defeat a bacteria? Is that a possibility?
Right now that's more science fiction than science. There's clearly lots going on in genetic engineering, particularly in trying to engineer people who have a genetic disease and the ability to turn that disease around and cure them from that disease. I think we're a long way from curing ourselves from having to worry about infections.
Darn it. All right, you've dashed my hopes. All right, we're going to take a quick break. We'll be back with Bruce in just a moment.
For information on how to help promote civil and mutually respectful discourse and support expansion of the distribution of our programs, please email info@harbertv.com.
The Rex Howell Broadcaster of the Year Award recognizes an individual who, through leadership, skill, and dedication, is advancing the broadcast industry in our state and our nation. Tonight, we honor Aaron Harber. Aaron has worked extensively in the media as a host, producer, political and economic commentator, and columnist. Today, the Aaron Harber Show is the focus of his media involvement. Aaron, it is a privilege to present you with the Rex Howell Broadcaster of the Year Award. Congratulations.
Just make journalism great again.
The Aaron Harber Show may be viewed 24/7 at no charge from any location in the world at harbortv.com.
Welcome back to the show. I'm with Dr. Bruce Gellin. So Bruce, what about harnessing our own immune systems to fight diseases? What do you see happening, looking ahead in the future?
Well, I guess, I'm biased because I've done so much work from an infectious disease standpoint about vaccines and the role that vaccines have for immune protection. I think that's actually where there's going to be the largest advantages. And not just for children, but increasingly across the lifespan. For a long time, vaccines was about childhood. Increasingly, and I think this is where some of the lessons we've learned from our investment in upstream science, some of the lessons in the immune system that we've learned from investigating the HIV epidemic have taught us a lot. And now we have vaccines at different points in lifespan. For children, which we've talked about, for adolescents, for adults, even for the elderly, and even for pregnant women. So I think that increasingly we see the opportunity that vaccines have to better prepare our immune systems from the diseases that could affect us at those different stages of life.
So, I know because you've worked in the federal government, you've worked for international organizations, I would assume this is not an area of expertise for you, but I am very interested in your take on the protection, especially now so many are electronic, of patient records and of medical data. We've seen in recent years breaches, serious breaches, which to me plays into people's loss of confidence in science and in medicine as well, because it's a function of, well, I can't even trust them with my own information. Why should I believe what they're saying about vaccinations or anything else? Give me your sense of how you see those challenges.
No, I think you're right. I think that people look at the system and they see what goes wrong with the system. They don't often see what goes right with the system because when it's working, you don't hear about it. But the reality is what you said, that when people see these parts of the system, they say, well, if they can't do this, why should I trust them to do that? And I think I think we need to be transparent about some of these issues, transparent about some of these glitches. I think there's a tension between what the opportunity that data has to have us better understand a whole range of things about health, and yet, as you said, that protecting that data so that it doesn't cause individuals harm. I know that people talk about that all the time, and they worry about that. And when you see these kind of breaches, that's of concern. And your larger point is really an important one. That it's about confidence. It's confidence in science. It's confidence in the way it's conducted. It's confidence in government, and the degree to which that there's real attention paid to those things to minimize those risks is I think really important.
Are we doing a poor job of educating the public about science?
The report that came out this week from the Wellcome Trust, I think, speaks to this issue about what people understand about science, their trust in science. And what I found particularly interesting was sort of the difference between people's trust in science versus what their trust in scientists. And I think that I extrapolate that to the same kind of thing we talked about before with people getting information from their healthcare provider versus the system. So I think the importance of recognizing that there are real people that are just like them that are doing these kind of jobs and doing a great job with their jobs and trying to bring the best products to people. So I think we need to better understand that. I think scientists aren't doing a very good job of going out there and explaining their science, and I think that this report, I think, is telling us about that. I think that the scientists often don't talk to journalists very well, and we need to better understand that because journalists need to help with that story like you're doing today. And it happens with real media and social media, but people need to explain what it is that they're doing and to explain science.
Well, think about, too, in the context of today versus 40 or 50 years ago, in terms of the work a scientist was doing, a medical researcher was doing. 40 or 50 years ago, the odds were it was relatively broad-based, that you were taking on big topics. And I would argue today, but tell me if I'm wrong, that the people doing research today, there are many, many more of them, and they're often very highly specialized in a very specific arena. And because of that, their ability to communicate with the public they may feel inhibited because of the level, the technical level at which they're working. Tell me why I'm wrong.
Well, nobody won a Nobel Prize for science. They won it for very specific things, and that's been going on for 100 years. So people have always worked on specific science. I think your point is an important one, though, is the ability of somebody who's working on something very technical to translate that to their neighbor, to explain it as what they do. And I think that's where we need to, because everything that they're doing has some relevance. I know that when we review proposals to the National Institutes of Health, people are working on some arcane molecule. The opening paragraph says, and if we better understand this, we're going to be able to cure this disease. So I think that that's something that scientists can better do to project outside of their laboratories what it is that they're doing, why they're passionate about it, and how that fits into the bigger picture.
All right, we're going to take our last break. We'll be back with Dr. Gellin in just a moment.
For information on how to help promote civil and mutually respectful discourse and support expansion of the distribution of our programs, please email info@harbertv.com.
I'm Aaron Harber, host of The Aaron Harber Show. I very much would like to hear from you about the program, so please send me an email with your thoughts. You can suggest what topics I should cover, what guests I should invite to be on the show, or even what specific questions you would like me to ask. This is your program, so send your suggestions to aaron@harbertv.com. I promise to personally read every one, so email me today. And most of all, thanks for watching.
Safely stop fires around your home. Introducing the Fire Ice XT 20-ounce aerosol canister. Fire Ice XT is an eco-friendly water-based fire suppressant gel. Unlike a traditional fire extinguisher, Fire Ice XT is a highly effective, non-toxic firefighting agent that is easy and safe to use around your home, family, and pets. Available at Amazon.com or call 800-924-4874.
I'm Aaron Harber, host of The Aaron Harber Show. Find us on Facebook to get all the latest updates, see behind-the-scene photos, and make comments and ask me questions. You can see episodes before their TV broadcast, so like the show today.
The Aaron Harber Show may be viewed 24/7 at no charge from any location in the world at harbertv.com.
Welcome back to the show. This is our final segment in part 2 of our special 2-part series with Dr. Bruce Gellin. Both part 1 and part 2 are available online for your viewing pleasure. So I'd be really interested in, given the number of different vaccines, how many vaccines can the human body take on at once? And does it make sense to space these out? Are there formula for that? And do we know about the interaction of vaccines if you get multiple vaccines at the same time?
That's really an important question because many people ask that, both the science community and the parent community. I think what this is really telling us is how amazing the immune system is, and what we're learning about the immune system, and we're learning more every day. And the immune system is designed to protect us from the bad things in the environment. And we don't get things in the environment just one at a time, but you never know what you're going to run into when you're in a forest, when you're on a subway, and the immune system is able to handle all that. It's quite complex. We don't have time to get into all that. I would be in over my head quite quickly, but I think the real lesson is the immune system is designed to take on all kinds of affronts. So when it comes to vaccines,
Simultaneously.
it doesn't know. But that's what it's designed to protect us from invaders. And vaccines are doing that one at a time. So as we test vaccines, we look at one at a time on how they work and the whole process of developing vaccines. And what people don't really understand is that in this process of developing, we learn along the way that not everything that was a good idea turns out to be a good idea, and they don't get very far in the development process. But those that work all the way through the system, that in the United States are approved by the FDA and then are recommended for all children or all adults, those have gone through quite a lot of testing to make sure that they have the protection before they're recommended. Need to make sure that they have the protection they're designed to have and are safe as well. And as new vaccines come in, those vaccines are looked at on top of what the existing recommendations are. So when we look at the childhood immunization schedule, which has gotten increasingly complex over time, each new vaccine that is developed has to be developed and compared with the existing set of vaccines. So they're layered on top of each other, and they go through that same set of tests.
So when they go through testing, are they going through testing? Obviously, they go through testing on their own, but do they also go through testing when the test subjects involved are getting multiple vaccinations?
Yeah, absolutely. So because these test subjects happen to be real people, and these real people are getting recommended vaccines because they're real people, when a new vaccine is developed, that vaccine is now put in the context of what they're getting anyhow. So in that way, they're layered on top of what they would get, because you can't withhold vaccines that they should get just to test it. So each new vaccine is now tested on top of all the others, and as they go through that process, they have to demonstrate that they can continue to work in the face of other vaccines, both in terms of the immune protection and the safety profile.
In the next 1 or 2 decades, what do you foresee in terms of the advancement of vaccine technology?
I think that what we're seeing now is the change from the way vaccines used to be made, by killing an organism and grinding it up, or an organism where it just becomes a weakened form of itself, to actually now understanding enough about the immune system to be able to design a vaccine to get the impact that you want. So I think that another part of vaccine technology, it gets back to what we talked about in part 1. Another part of the vaccine technology is what we talked about in part 1 of this series about bioterrorism and preparedness for the unknown. So increasingly, we're going to need to have vaccine technology that is nimble enough so that when some new virus emerges, we can relatively quickly develop a vaccine and deploy a vaccine for it.
So let's talk about the flu, because that has huge consequences for millions of Americans every year. One of the challenges with flu vaccines is that those making the vaccines each year don't always know which versions or variations of the flu are going to be widespread. How do we do a better job on that challenge so that the vaccines are actually much more effective than they've often been, number one? And number two, what's the outlook for some kind of lifelong universal flu vaccine?
So if I could, I think that we also need to understand that not everything is influenza. Everything is called the flu, whether you have a stomach ache or a headache or an itch. And I think that's part of the problem of the complacency we have about flu, is because, everybody's had flu and they've gotten over it, why do we need this? But the more important point that you raise is about how we need to have better vaccines than we have now. Right now, because the virus mutates regularly, we have to look at what the viruses are likely to be, and then tailor-make our vaccine each year to anticipate those viruses. We're pretty good at it, but not perfect, and need to get better at that. Even better than that would be if we could develop a vaccine where we didn't have to guess each year, but a vaccine that could protect against any of these mutated viruses. This is the universal vaccine. So I think both of these things are going simultaneously. Improvements in our current technology so that the vaccines we make are better and can protect more people, but in parallel to have a moonshot, if you will, on developing this universal vaccine so that we can really take the threat of influenza, both seasonal influenza and these pandemic threats that occur periodically, take them off the table.
So on the moonshot front, who's doing that research? Is that federally funded research? Is that pharmaceutical companies that produce vaccines? Who's doing that?
So that's an important question. It's such an important topic that many people are doing it. It's going on in the public sector, not just the United States, but around the world. It's going on with companies who are currently making influenza vaccines, try to make improved vaccines. There's a whole number of people in the biotech sector who see the opportunity of leapfrogging to these new technologies, and a number of philanthropies are involved with as well. You may have seen a year ago, Bill Gates called for a grand challenge on universal flu vaccine. And what he asked for, he said, we need new thinking. We need new science. We need to bring people who don't think they have a solution to this problem to the table and help us look at this problem differently. It's all going on.
Is there any disincentive for companies that make vaccines today, any financial disincentive to have a universal and or lifelong lasting vaccine in terms of the loss of revenue?
I think you could look at that. I think that from a short term, I think that's a concern. But I think from the long term, I think there's going to be winners and losers. And the real concern will be if you're a loser. And if somebody else develops this product, which is the one that everybody wants and is going to produce it, then no one's going to want to buy the vaccine that you have.
Is there any threat to human health in terms of the use in the veterinary field of vaccines?
I think it may be the flip side of that. Because we know that many of these emerging infectious diseases, I think maybe 70% of these emerging infectious diseases, from pandemic influenza to Ebola to SARS and some of these others, comes from the intersection of the animal infections, animals and humans, that we know that we're at risk for that as well. So I think that if the more we can prevent animals from getting sick, the more we can reduce that as well. Clearly, there's a difference between the animals who we're able to vaccinate and free-range animals for which we don't. But I think that's where we need to pay our attention of that human and animal interface.
Okay, only a couple minutes left, couple quick questions. One of the really interesting aspects is what travel and how pervasive travel has become, where humans are going into areas that have new diseases where we didn't tread before. What's that challenge like?
I think there are two challenges to travel. One is traveling to places that we're familiar with, and we could get diseases that we're also familiar with. That over the past several years, measles has been quite prevalent in Europe, and a number of travelers have come back with measles. We often see that there are travel advisors for people traveling to Europe. At a soccer game years ago in Europe, the first thing on their homepage was, if you're coming to this game, make sure you're protected against measles. So I think there's that part of travel, which is why it's important to understand what might be happening in any part of the world, and to make sure that the vaccines that are available, that you have and that you're protected. And then there's the part where going to places where you might get some exotic infection. I think that happens, and we see that. And I think that we just need to make sure that when people go to those places, they tell us when they come back and they get sick, tell us where they came from. But increasingly, there are new technologies that can help to identify even these new viruses.
And on the global front, tell me a little bit about where we are in terms of the status of vaccines and vaccine use.
That's a great question, and that front has changed dramatically in the last 20 years. 20 years ago, a group called Gavi, the Global Alliance for Vaccines and Immunizations, was started. And the idea it was started with the recognition that there were a number of vaccines that were available in the developed world, and why couldn't they be available more quickly in the developing world? It was largely about financing, and came an ability to actually to think about a new way where you could make large purchases and then deploy those vaccines. Wind the clock forward, and there's been massive improvement in the delivery of vaccines. There's still a long way to go. Still, one in five children is still not getting the vaccines they need. There are still challenges, but that picture has changed dramatically in 20 years.
All right, I know we're out of time, but one last question. If you could change one thing on the planet which you think would have the greatest impact, what would it be?
I think clearly the greatest positive impact would be what we've already seen in large ways in the developed world, and in increasingly large ways in the developing world, is the ability to prevent diseases and their consequences that are preventable. These have implications on health, they have implications on education, they have implications on society, and from a perspective of somebody who's studied and practiced infectious diseases, the more we can prevent these infections from happening, the better the world will be.
All right, Bruce, thank you so much.
Thanks a lot.
All right, that was Dr. Bruce Gellin. I'm Aaron Harber. Thanks for watching.
Please contact us. We want to hear from you. And thanks for watching.